The graph of a function y versus x is given, and we want to identify the minimas and maximas here. So this point is a minima, this point is a minima, this point is a minima, while this point is the most minimum value of the function. So this point is normally called the global minima, and these are called the local minimas. Similarly, the maximas, if we identify, this is a maxima, this is a maxima, this is a maxima, and this one is the ultimate maximum value. So this one will be called the global maxima, while these ones are the local maximas. So if the graph is not given, if the analytical expression of the function is given, say y is function of x, the way to find the maxima or minima, which is also called stationary points. Stationary points can be a maxima or minima. So all these points are called stationary points. So to do that, because we can see that at these points, maxima and minima points, stationary points, the gradient of the graph becomes 0. So what we should do, we find the grade y prime there. Y prime is function prime x. So and equate it to 0, because the gradient will be 0, and then we solve it for x. We find the value of x for that y prime is equal to 0, and so that point will be either a maxima or minima. And in order to know whether it's a maxima or minima, what we do is something called a point test. So basically finding this one. So this point is where the maxima or minima is there. So the f prime x will be 0. So we see what is the gradient on the left of that point and what is the gradient on the right of that point. So we can see if this one, the gradient here, the gradient is 0, but just on the left the gradient is a negative and just is a positive, and just on the right the gradient is a negative. So this one means if this will be the nature of a maxima point, because the gradient will always be negative on the left and positive on the right. Similarly, if we look at a minima point, like say this one, on the left the gradient is a negative, and on the right the gradient is a positive. So if this one is a negative here, and on the right if the gradient is positive, so this one is like that. So this point is the stationary point, this one becomes a minima here. So we can say that this is a minima. Similarly, if we do the point test and we see that the gradient is positive here on the left and negative on the right, that means this is like that and that, the gradient. So this point has to be a maxima. So this is called point test. This way we can know whether the point is a maxima or minima. There is another way, which is called finding using the second derivative. So what we do, we find the second derivative and look at the sign of the second derivative at the stationary point. So if the second derivative is greater than 0, the point is a minima. And if the second derivative is less than 0, the point is a maxima. And why we will discuss later when we talk about the curvature, concave up and concave down thing. So for now we can remember that if the second derivative is positive at the stationary point, that means it's a minima, and if it is negative, that means the stationary point is a maxima. Now it depends on the function. If finding the second derivative is rather easy, then we should use the second derivative test. And sometimes all the functions won't have a second derivative. So if the second derivative exists and if it is easy to find that, then we should do this one and the second derivative test, or we can do point test depending on the function. For some function, doing point test will be easier. For some function, doing second derivative will be easier. So it will depend on the function. We should choose the appropriate one depending on the problem in hand. So yeah, this is a little bit about maxima and minima as stationary points.